Hi, it's time for another math easy solution, and now we're going to discuss further into application of integrals and look at further into moments and centers of mass and look at example 1. In this example, we're not going to use integrals. I'm just going to go over a very simple example on finding the moments and centers of mass. And in later videos, I'll go over it using integrals for more complicated examples. So again, make sure to watch my earlier video on Introduction to Moments and Centers of Mass, which I use the equations to solve this example, which states, find the moments and center of mass of the system of objects that has masses, that's right, has masses 3, 4, and 8 at the points -1, 1, 2 and -1, and 3 and -2 respectively. Let's say, assume they line up. So if we were to draw this out on the XY axis to get a better idea, so let's draw this like this. Draw a better line. Okay, so this is our axis or Y. So let's say the first point here, this is at, I'm just going to call it, I'll write down 1 later, but anyways, so the first point's at -1 and 1, so -1 and 1. So that's the X and Y coordinates. And what I'm going to do is draw the size of the masses, relative masses, just to get a better idea of where the center of mass should be. So 3 is the smallest one, so it goes something like that. So that's a mass of 3. And now let's look at the next point, 2 and -1. So 1, 2, and -1. So this is, say -1 is over there, and it's a mass of 4, so it's bigger. It's bigger than the 3, so we'll just draw it roughly bigger. So 4 like that. And the last point is a mass of 8. It's at 3 and 2. And then so 2, so it goes somewhere here, and it's by far the biggest one. Let's just draw it relatively this big. So if you have something like this, the center of mass, if you have a bunch of weights like this, you have a flat plane, you would assume that the center of mass is going to be, well, somewhere around here, I would assume. Because this mass is carrying everything towards it, and this is carrying it everything more to the right, where this is the lightest one. So it should be somewhere like that, I would assume. So let's just start to solve this. So let's write solution. And the solution, well, what we're going to do is recall, so recall the formulas for moments. So recall moments in my last videos, moments, formulas. And the moments are the tendency to rotate about each axis. So the moment about the x-axis, this one is going to be the summation of from I equals 1 up to n of the multiplication mi, which is mass, times it by yi, which is the coordinate, the y coordinate. And that's the tendency to rotate this about the, basically rotate about the x-axis. So that's the moments and multiplication of that distances across. So for example, this one here would be, this is y 3, because that's our third one. And m3 is equal to 8. So that's our mass there. So that's just an idea. And then the rotate about the y-axis moment is going to be the summation I equals 1 up to n of mi times it by x. And again, exact same thing, but now it's a tendency to rotate about the y-axis. So we're going to be looking for this all the way up to here. This is going to be our x3. Okay, so now the centers of mass formulas, let's write that down. Recall centers of mass. And again, I showed these in my in the last video. So centers of mass in the x coordinate is going to be x with a line above it, and this is going to be m. This is my divided by mass of the moments about the y-axis divided by the mass m. This is total mass, and the y coordinate of the center of mass is going to be equal to moment mx, the summation divided by m, the mass, where again m is equal to summation I equals 1 up to n, and this is where mi. This equals to, well, total mass of the system. So let's begin solving all of this. So for the first one, my, or I think this is mx. So mx, which is right here, summation mi times by yi. So this one, since we have three objects, we'll have mass 1 times by y1 plus mass 2 times by y2 plus mass 3 times by y3. And what we have here is these are the masses. We'll call m1 as 3 and 4 as m2. And then this is m8, mass 8, which is m3. And then the coordinates right here, this one is x1, y1. This is x2, y2, and this last one is x3, y3. So let's put these down. So 3, 4, and 8. Then we have for the y values 1, -1, and 2. So this equals to 3. And then plus, I'll add those up later. So this is 4 multiplied by the y2 plus this is 8. And then let's just get the y's again. So this is 1, -1, and 2. So 1, -1, and 2. Now let's just multiply this out. This equals to 3 minus 4 plus 16. So -4 plus 16, that equals to 12. So 3 plus 12, this equals to 15. So the moment about the x-axis, mx, is 15. And now let's solve for my, where we have m1 times it by x1 now. x1, the one like that, plus m2, x2 plus m3. This is going to be x3, where again, this is going to be 3 times by this one plus 4. Just because I remember the masses, 4, 8. And now let's find out the x's here. That's x1, so -1, 2, and 3. So -1, 2, and 3. So multiplying this out, we get -3 plus 8. And here we have plus 24. 8 times 3 is 24. So multiply this out, add this up, 8 plus 24 is 32, so we have -3 plus 32, so subtract this is just 29. So that's the moment about the y-axis, or my. Now let's start solving for the centers of mass, this part here. Let's first find the mass. The mass is going to be, well, m1 plus m2 plus m3, which equals to 3 plus 4 plus 8, which equals 2. This is 3 plus 4, 7 plus 8 is 15. So that's the mass. So what we get now is the x-coordinate is going to be equal to, x-coordinate of the center mass, my divided by m, which equals to, well, my is 29. Divided by m, which is 15. And again, just to write this simpler, this is going to be, we could write this as 15 plus 14, that equals 29, divided by 15, so this could be 1 plus 14 out of 15, which also you could write it as equaling 1 and 14 out of 15, where this is a mixed fraction. So 1 and 14th of a 15, or however we call it, a mixed fraction, so it's basically close to the value 2. So that's what that is, just to get just easier to graph. And now the center of mass for the y-coordinate is going to be mx. So the moment about the x-axis divided by total mass, and this equals 2 mx. Scroll up. Mx is 15, and mass is 15. So 15 over 15 equals to 1. So what we get is center of mass is equal to, it's at the point, basically at the point x and y. So at these points with these line above So those are the coordinates we just solved. That's 1 and 14/15, and this is going to be 1. So that is the point, and we'll just highlight this. And now let's draw it out. Remember when we showed before that it was supposed to be around this area, and in fact it actually is. So 1, this is 1 here. So 1 and 14/15, so it's pretty much somewhere around here, and at the value 1. So the center mass is pretty much here. And this is at 1 and 14/15, so really close to 2, and 1 for the y value. And we could write this, I'll scroll an arrow. This is the center of mass of this system of masses here. And as you can see, it should be like that because you have the biggest mass 8, so it should be closest to it. And you have the big mass here 4, so it should push it away further from the 3, and that should be obviously the farthest away. Anyways, that is all for today. If you learned from this pretty interesting example on center of mass, and later videos will show more complicated masses that requires integrals, so stay tuned for that. Anyways, that's all for today. Hope you learned from this video, and like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.